Hi everyone, this is Abhilash Ullala, Assistant Professor of Mathematics, Department of Freshman Engineering, St. Martin's Engineering College. Today I am discussing about the wave equation. In that we are discussing about the one-dimensional wave equation. It is wave equation is a second order linear partial differential equation which is useful to describing the waves and the standing waves which are obtained in by a stretched string or a spherical waves obtained in a point of source. It is here a wave equation is taken by a motion of a string. We are considering a stretched string with a length of 0 to L, and the displacement function we are consider as u of x comma t. According to a wave equation, here at any position the acceleration perpendicular to the given string is proportional to the curvature of the string. It is here the equation of the one-dimensional wave equation is given by rho into dou square by dou t square is equals to t into dou square by dou x square. It is here the x can be treated as position and t is the time and rho is the mass per unit length and t is the tension. Here these are the parameters that we can use in this equation: position, time, the vertical displacement, tension and mass per unit length. Here the solution of the one-dimensional wave equation is considered by using the variable separable method. Here u of x comma t is considered as x of x and t of t. By using of this function, the one-dimensional wave equation, here it will be converted to x of x into t double dash of t is equals to c square x double dash of x t of t. It is this can be solved using separating of variables in the two different forms. Here the equation can be taken in the form of x double dash of x by x of x is equals to t double dash of t by c square into t of t, which is equated to lambda. Here we can consider that we can convert that into x double dash of x minus lambda into x of x equals to 0 and t double dash of t minus c square lambda c square into t of t is equals to 0. Here we can write these equations in the form of a differentials, that is d square minus lambda into x is equals to 0 and d square minus lambda c square into t is equals to 0. Here we can write the auxiliary equation for this differential equations, that is m square minus lambda is equals to 0 and m square minus lambda c square is equals to 0. Here u of x comma t is taken into two separate functions, x of x and t of t, that is substituted in the equation of utt is equals to a square into uxx. Here in that will be converted to t double dash of t by c square into t of t is equals to x double dash of x by x of x is equals to lambda, that we are consider here for making that into a differential equation. That differential equation is in the form of x double dash of x minus lambda into x of x is equals to 0, t double dash of t minus lambda c square into t of t is equals to 0. This can be written in a differential equation form, that is d square minus lambda into x is equals to 0. Here it can be written as d square minus lambda c square into t is equals to 0. The auxiliary equation we can write here for these differential equations is m square minus lambda is equals to 0, comma m square minus lambda c square is equals to 0. According to this lambda value, here we get different type of solutions for this auxiliary equation. The roots will be varies according to the lambda value. If I consider lambda is equals to 0, then this equation becomes as m square equals to 0 and this becomes as m square equals to 0. here we can write the roots m is equals to 0 comma 0. Here we can write that as m is equals to 0 comma 0. Because the roots are 0 comma 0, here we can write the solution of x of x as c1x plus c2. Here the t of t solution is c3t plus c4. If I consider lambda greater than 0, then if lambda greater than 0, then the equation has become as m square minus lambda is equals to 0 and m square minus lambda c square is equals to 0. For our convenience, here I am considering as lambda is equals to k square, because the lambda is in a positive value, I am considering it as k square. By substituting of k square, m square minus k square is equals to 0 and m square minus k square c square is equals to 0. Here we get the roots of this equation, m is equals to plus or minus k, and here m is equals to plus or minus kc. We get the solution, we can write the solution of this equation in the form of x of x is equals to c1 e power lambda k e power kx plus c2 e power minus kx. Here we can write the solution for t of t is equals to c3 e power lambda c kct plus c4 e power kct. Next, if we consider lambda is less than 0, that I am taking as lambda is equals to minus k square, then the auxiliary equation becomes as m square plus k square is equals to 0 and m square plus k square c square is equals to 0. Then we got the roots m is equals to plus or minus ik. Here m is equals to plus or minus ikc. So we can write the solution of x of x here c1 cos kx plus c2 sin kx. The t of t solution is c3 cos kct plus c4 sin kct is become as the solution of the equations. Here for the stretched string, here we can get the boundary conditions. The boundary conditions are, here the string is stretched with the fixed length, that is 0 and L it is. Here the value is 0, the displacement is becomes as 0 because it is fixed at the end of 0, then the displacement is become as 0, then x of 0 into t of t is equals to 0, and the another end is L. At that position also the string is fixed, so the displacement becomes as again it is 0 it is. By using of these two conditions in the earlier obtained things, here in the earlier we have got the solution as x double dash of x minus lambda x of x equals to 0. According to the three conditions, lambda equals to 0, lambda greater than 0 and lambda less than 0. When the lambda is equals to 0, the equation would not satisfy the boundary conditions, and when lambda is greater than 0 is also, the equation should not satisfy the boundary conditions. The boundary conditions are satisfied whenever only the lambda is less than 0 for x of x. Coming to the t of t solution, here also we got the three different solutions for lambda equals to 0, lambda greater than 0 and lambda less than 0. If lambda equals to 0, the same boundary condition that we can apply here, which would not satisfy whenever lambda is equals to 0 and whenever lambda greater than 0, we get the exact solution, correct solution for the t of t whenever the lambda is less than 0 it is. The common solutions of x of x and t of t are that after substituting of equations, after substituting of boundary conditions, here we get the solution as x of x is equals to c1 sin n pi x by L and t of t is equals to c3 cos cn pi t plus c4 cn pi t. The combined solution of these two is given as u of x comma t, which is x of x is equals to c of t, that is c1 sin n pi x by L and c3 cos cn pi t by L. Here the multiplication of these two variables at c1 and c3 and c1 and c4 we are considered as the C1 and C3 is equals to A and C1 and C4 is equals to B. That constants we can write here, u of x comma t is equals to x of x into t of t, that is sin n pi x by L into A of cos Cn pi t by L plus B into C sin n pi t by L, where n is equals to 1, 2, 3. Here we get the n values when we are applying the boundary conditions to the existing solutions of x and t of t. We get the condition for n may be any value of 1, 2, 3. Here we are converted a wave equation into a sinusoidal modes, which will useful to find the propagation of the wave and also the amplitude, frequency and the periods of the wave equations. Let us go with a problem. Solve the initial boundary value problem utt is equals to c square into uxx with the boundary conditions are u of 0 comma t equal to 0, u of L comma t equal to 0, and the initial conditions are given as u of x comma 0 is equals to 0 and ut of x comma 0 is equals to lambda x L minus x it is. So since the boundary conditions are same as earlier, the solution of the given wave equation is become as u of x comma t is equals to sin n pi x by L A into Cn pi t by L plus B into Cn pi t by L. Let us go with a problem. Solve the initial boundary value problem utt is equals to c square uxx with boundary conditions u of 0 comma t equals to 0, u of L comma t equals to 0, and the initial conditions u of x comma 0 equals to 0, ut of x comma 0 equals to lambda x L minus x. Here the boundary conditions are same what we had taken earlier, and the initial conditions are given as ut of x comma 0 is equals to lambda x L minus x, u of x comma 0 is equals to 0. Here since the boundary conditions are same, then we can take the earlier solution for the equation. What is that is u of x comma t is equals to x of x into t of x, the variable separable equation that we are solved as sin n pi x by L is into cos of Cn pi t by L plus B into sin Cn pi t by L, where n is equals to 1, 2, 3 and so on. The same solution that I am considering here for finding the solution of this equation. Here what is the condition is given as an initial condition. The first initial condition is given as u of x comma 0 it is. By applying of this condition in the given equation, what we can get it as u of x comma t is equals to the equation of the solution of the wave equation u of x comma t is equals to sin n pi x by L by A into cos Cn pi t by L plus B into sin Cn pi t by L. Here we are given the initial condition as u of x comma 0 is equals to 0. By substituting of this condition in the above equation, what we get that is that it become as 0 is equals to sin of n pi x by L into A of cos of 0 plus B of the sin of 0. Here the cos 0 is 1, sin 0 is 0. So what we get here, we get as A into sin n pi x by L is equals to 0. Whenever the sin n pi x by L is equals to 0, what we have to write it is that n pi x by L is equals to n pi, then x is equals to L. That is well known for us, the length of the string is L it is. So here we cannot write the sin n pi x by L is equals to 0. Here we have to consider that A is equals to 0. If this A is equals to 0 is substituted in this equation, then that equation will be converted to what we get here, that A term will become as 0 and the B term we get as a multiple of u of x comma t. So that equation becomes as u of x comma t is equals to b into sine n pi x by L into sine of Cn pi t by L. For this, we have to find the solution of the given wave equation by using the second initial condition. The second initial condition is given as ut of x comma 0 is equals to lambda x into L minus x. Ut of x comma 0 is equals to lambda x into L minus x. Now we have to apply this condition here for the equation. We know that the n value will carries for 1, 2, 3. According to the superposition principle, here we can write the solution of this equation by using of the sum of all the solutions of for n is equals to 1, 2, 3 and so on. It is u of x comma t is equals to summation n is equals to 1 to infinity bn sine n pi x by L into sine Cn pi t by L. This becomes as the solution for all the n values, that is a combined solution for all n values it is. Now we can apply the boundary condition here. What is the boundary condition is ut of x comma 0 is equals to lambda x into L minus x. Now apply the derivative for this equation, that is dou by dou t of u of x comma t. U of x comma t is equals to summation n is equals to 1 to infinity bn. The sine n pi x is constant according to the t, so it will be treated as constant, and we can apply the derivative for the sine Cn pi t by L. By applying of derivative to this Cn pi t by L, here we get the derivative is ut of x comma t is equals to summation n is equals to 1 to infinity bn sine n pi x by L of the sine derivative is become as cos Cn pi t by L into the constant term in this, that is n pi c by L we get as the constant term. Now what we have to apply here, the condition is given as u of x comma 0 is equals to lambda x into L minus x. Now apply that 0 at the place of t in the equation. By applying of t is equals to 0 in the equation, what we get, that is ut of x comma 0 is equals to summation n is equals to 1 to infinity bn sine n pi x by L into this becomes as cos 0 into n pi c by L, which is equals to u of t of x comma 0 is equals to summation n is equals to 1 to infinity. I am writing the constant before, that is n pi c by L into bn into sine of n pi x by L. This will be equals to, what is the given condition is lambda x into L minus x. Now equate that lambda x into L minus x is equals to summation n is equals to 1 to infinity n pi c by L into bn of sine n pi x by L, which is in the form of a Fourier series of half range Fourier sine series. Summation n is equals to 1 to infinity. This will be treated as a constant n pi c by L into bn of sine n pi x by L. U of x comma t we are obtained as n is equals to 1 to infinity n pi c by L bn sine n pi x by L, which is in the form of half range Fourier sine series that we can solve by applying of the condition that lambda x into L minus x. Here the solution of the Fourier series that we can take in the form of n pi c by bn, n pi c by L into bn is equals to 2 by L into 0 to L lambda x into L minus x sine n pi x by L into dx. Here the value of L is given by the length of the string and the limits are 0 to L it is. By applying of integration to that, here we have Lx minus x square. The integration of this function of sine n pi x by L we are writing as that minus L by n pi cos n pi x by L, and the derivative of Lx minus x square is L minus 2x. That the derivative of the cos n pi x again it is minus L square by n square pi square sine n pi x by L, and the derivative of L minus 2x is minus 2, and the derivative of the sine pi n pi x is L cube by n cube pi cube cos n pi x by L. The limits are 0 to L it is. These limits are, we can substitute in this equation. What is the upper limit is? Here the upper limit is L, that we can substitute in place of x is equals to L in the equation and x is equals to 0 in the equation it is. By substituting of x is equals to L and x is equals to 0, if we substitute x is equals to L here, this term becomes as 0 and this L minus 2x becomes as minus L, and this becomes as sine n pi by L, and this becomes as sine n pi by L and cos n pi by L it is. By substituting of lower limit, this becomes as 0 and this becomes as 0 and this becomes as minus 2 L cube by n cube pi cube. The combined solution is becomes as the 4 pi L square by n cube pi cube 1 minus cos n pi. This 1 minus cos n pi, the cos n pi we can write as 4 pi L square by n cube pi cube 1 minus of minus 1 whole power n. This 1 minus of minus 1 whole power n is equated to the n pi c by bn. What n pi c by bn, this term we got from here, that the Fourier series term, that is constant is n pi c by L into bn, that we are equated to the solution it is, that is n pi c b by L bn is equals to 4 lambda L square by n cube pi cube into 1 minus cos n pi. By equating of that and taking this term is to right hand side, that we get the bn value is equals to 8 lambda L cube by c into 2m minus 1 power 4 pi by pi power 4, taking n is equals to 2m minus 1 it is. Here we are taking n is equals to 2m minus 1 because if we take n is equals to 2 here, then this term becomes as 1 minus of 1, that is equals to 0. So here this term completely becomes as 0 when n is an even number. So here we are considering as n is an even number, the solution becomes as 0. So we are taking only the odd numbers, that n is equals to 2m minus 1. This bn term here we are going to substitute in the solution of the equation. Here the solution of the equation is given by this equation of bn is equals to y of x comma t of bn sin n pi x by L and sin n pi c t by L. That bn can be substituted here. We get the final solution of this equation as summation m is equals to 1 to infinity, that 8 lambda L cube by c into 2m minus 1 power 4 pi by 4, and the two sign terms we get with the values of 2m minus 1 pi x by L and 2m minus 1 pi c t by L it is. This becomes a solution according to the boundary conditions given for the problem, that u of x comma 0 and ut of x comma 0 equal to lambda x into L minus x. Here the after the boundary condition, the solution is obtained as an infinite sum of all the possible solutions for the equation, that for m is equals to 1 to infinity it is. Here the usage of this solution of the variable separable is to convert into sinusoidal modes, which will useful to visualize the equation and how the amplitude and frequency and the propagation of speed of the wave will be changes here. Here let us go for a video for visualizing the effects of the propagation speed, what we are taking as a constant here in the equation as c square, as how the c square will be varies the propagation speed of the wave, that we can visualize here in this video. Here the video consists of at the different points of a values. Here we can see the propagation speed of the wave equation. It is, I am going with the two boundary conditions, that is u of x comma 0 is equals to sin x, ut of x comma 0 is equals to cos x when a is equals to 0.1. The next is a is equals to 0.3. As the a increases, we can visualize, we can see the propagation of the wave is changes. The speed of the wave will be changes as a value will be changes. It is whenever a is equals to 0.5, and here the next is a is equals to 0.7. The speed is increased, the propagation speed is increasing for a wave with the same initial condition, that ut of x comma 0 and u of x comma 0. The next value is a is equals to 0.9. It is, you can see the wave equation is changed. The next initial conditions we are taken as u of x comma 0 0 and ut of x comma 0 is x into 1 minus x. Here the wave is decreasing down as we are changing the values of a in the fastest way, that decreasing into lower. It is, these two are represents the initial conditions of the wave. It is, here a is equals to 0.9. The next initial conditions we are taken as, the initial condition u of x comma 0 is taken as 6 sin x into e power minus x square, and ut of x comma 0 is equals to cos x. Whenever the value is 0.3, you can see the amplitude is changes. The u of x comma t solution according to the initial conditions we are got as that 8 lambda L cube C2m minus 1 power 4 pi by 4 pi power 4 in terms of two sine terms. Here we can see the propagation of the wave, how it will be varies according to the value of c square, what we are taking as a constant here in the equation. Let us go to the video of the propagation of the waves according to a value. Here it is, we are taken the initial conditions are u of x comma 0 is equals to sin x, ut of x comma 0 is equals to cos x, and a is equals to 0.1, and next is 0.3. Here as the value of a is increasing, the propagation speed of the wave will be increases, and the amplitude is also changes according to a value. The initial conditions are represented here in the red and green lines, that is u of x comma 0 and ut of x comma 0. It is, the next is a of 0.7 we can consider for the propagation of the wave. We can visualize that the amplitude of that wave is changing as a is changing, and the propagation speed is also varying. It is, for a is equals to 0.9. The motion of the wave, we can see the variation in the motion of the objects. The next is the hours initial condition, that is 0 and x into 1 minus the length I am taking as 1. As the a is changing here, the wave will be decreases in the axis of y. The next value is a equals to 0.7 and a is equals to 0.9. We can consider here for the value. The next initial conditions we are taken as the 6 sin x into e power minus x square and cos x. You can see the amplitude of the waves is changing from a is equals to 0 to 0.1 to 0.3, and the next we can consider as 0.5. The value of 0.5 we can consider here, the value of 0.5, you can see the motion of the wave that is changing drastically as a is changing from 0.5. The next is 0.6. 0.7. The next one is 0.9. Here, this type of analysis of the one-dimensional wave equation into the sinusoidal moves is applicable and useful for applied physics and engineering analysis, and also here we can use it in acoustics and electromagnetism and fluid dynamics of the different waveforms. Here we can have, in that we can apply the solution of these wave equations for finding solution. It is this content is useful to know the wave motion of the wave motion, and also we can know the amplitudes and frequencies of the objects. This we can end the session now. Thank you.